Most Obsidian content maps work fine at first. You create a few links, maybe a dashboard, maybe a dataview query, and everything feels organized. But as your vault grows, content maps quietly turn into maintenance work. You update links, you fix queries, you work around folder structures. At some point, the system that was supposed to save time starts creating work. So in this video, I will show you how to build content maps using bases that update themselves, stay fast at scale, and adapt to different contexts without duplication. Okay, so the issue isn't with content maps themselves. It's really about how we go about making them. For beginners, static content maps work okay because we don't have a lot of nodes and plugins can be a bit of a mystery. So we are stuck doing everything by hand. And every time we add or delete a node, it's like, more maintenance. Once we're cool with plugins, we find two we might like. Dataview, very powerful, and Waypoint, very specific for content maps. Both of them solve parts of the problem, but they also introduce new trade-offs. Dataview, super powerful, but let's be honest, there is a steeper learning curve than with bases, for example. Plus, it can really run into performance issues as we add more nodes. And Waypoint, it's fast and simple, but it's for folders and offers not a lot of flexibility. We will look at these trade-offs in detail in the comparison chapter later on in this video. So content maps do not fail because they're a bad idea. They fail because the underlying approach is either hard to maintain, does not scale, or both. What we really want is something dynamic, easy, and fast, no matter how big our vault gets. And this is where bases comes in. So what makes bases different and why does it work so well for content maps? Well, bases is not about links or folders. It's all about data. More specifically, data in our front matter properties. This lets us define rules and filters for the nodes we want to see in our content map. These rules can be based on folders, tags, or any property in our nodes. We can even use them to group our nodes. Combined with the different view types, this gives us great flexibility to build the best content map for each purpose. And of course, the content map updates automatically as our nodes and our vault change. There is no manual maintenance and there are no broken links. Bases is also designed to be fast. Even with many nodes in a folder or across your entire vault, there is no noticeable performance penalty. Another important benefit is reusability. We can use the same bases view in multiple nodes, dashboards, or contexts. We define it once and it stays consistent everywhere. And if we need a different view, well, we do not need to create a new base. We just add a view to the existing one, making our content map system very easy to maintain. Okay, let's dive into how we can actually use it step by step. Alright, so we are going to dive into 3 cool ways to map out our content using bases. We start off very easy with a content map based on a folder. Then we kick it up a notch with content maps that use tags. And finally, we build a fully property-driven content map. Plus, we will see just how simple and flexible it is to create different views for various purposes. We will build the same folder-based content map twice, once with bases and once with dataview, so we can see the difference immediately. So let's jump right into the first one. I prepared a separate vault with 3 folders called folder A, B, and C. They all contain some demo nodes. We have 10 nodes in folder A, 100 in folder B, and 1,000 in folder C. First, we create a new basis file in our root and call it dynamic MOC, like map of content. As always, we initially get a list of all the nodes in our vault. So we click on Filter and limit the results for all views to markdown files. This is optional, but for me it's good practice to make sure that I really get only my nodes and nothing else. Then we set a filter for this specific view to File Path starts with folder A. Lastly, we right-click on the view and rename it to folder A-all. This gives us a list of all the nodes in folder A. Then we create a new node in folder A called folder A-bases MOC. Here we embed our dynamic MOC. We can modify the view here or in the bases file directly. The result will be the same. Now, let's rebuild the same content map using dataview. We create a node in folder A called folder A-db for dataview, and here we insert this dataview query. This does exactly the same as the basis view on the left. It returns a list of nodes in folder A. My demo nodes contain several front matter properties. So what if we want to see those too? Well, in basis, we just click on properties and select the ones we want from the list. They show up automatically, we can rearrange the order, and we can even update their values directly in the table. This means that the content map is not just a view anymore. It becomes a tool to interact with our nodes without having to open them. Let's do the same with dataview. Here, we need to know the field names, type them into the query, and need to be aware that a property name like checked ? Does not work. So we have to skip this question mark, otherwise we would break the query. If we do all that correctly, we get a similar view as with basis, but without the possibility to update values directly. And what about sorting and grouping the results? In our basis view, sorting is instant. We simply click the column header. We can also use the sort button above the table. And this is where we can also select a property for grouping. For example, the status property. To get the same result with dataview, we need to rewrite our query like that. This is not quite as simple as one would hope. As you can see, already with these simple examples, bases are much easier to use. So far, we returned files from a defined folder, folder A. Let's make this dynamic by returning files based on the currently active file. So if we are in a file in folder A, we get results for folder A. And if we are in folder B, we get results for folder B. You get the idea. If we want results from other folders, we can simply right-click on the current view in basis, click on the three dots and on duplicate view. Let's call it folder B-all. We then just adapt the filter options for this view, and that's it. But there is a better way. For a view that returns results based on the currently active node, we can create a new view. Let's call it this folder. And for the this view filter, we switch to advanced filter and enter this little snippet. Now, even if you don't know anything about the basis syntax, you will understand what happens here. The filter looks for all the nodes that are in the same folder as the currently active one. This is the point where folder-based maps stop being static structures and start behaving like a system. We can now take the basis file, dynamic MOC, which we created initially, and drag it to the side panel. If we select the view, this folder, the list of nodes updates whenever we open a node and return only the results of this node's folder. And that's how we build dynamic content maps based on a defined folder path or based on the active file's location. The principle is very simple. One base, multiple views, zero duplication. Folder-based content maps are very useful, especially dynamic ones. But they still assume that every node belongs to exactly one place. As soon as a node appears in more than one context, folders limit us. Fortunately, Obsidian lets us use tags for this case. So let's build a tag-based content map next. Folder-based content maps assume every node belongs in one place. Tags remove that restriction completely. We can easily find nodes based on context rather than location. Regardless of where they are stored, our content map will show them. And here is how that works. We are back in our dynamic MOC basis file. I also opened one of the demo nodes next to it. We duplicate an existing view and click on Filter, and for this view, we define a filter for file tags, contains, and select tag 1. As we have no other filters or conditions set, this returns all the nodes in our vault that have the tag 1. And as you can see, this also includes nodes from the other folders, not just the one we're currently in. And because I just copied a view that includes various properties, I can edit those properties directly in this view too. Let's change a few values for the node A001. And you can see them happen in real time next to the basis view. And what if we don't want a plain list or table? Imagine these nodes were recipes or book nodes. they would most likely have an image included. So here is a neat trick for you. Let's right-click on the view name and change the layout to cards. Then we click on Properties and Add Formula. Let's call it F, like formula, first image, and paste this snippet. This simply looks for images embedded in a node and then returns the first one it can find. We right-click the view name again, and under Image Property, we select the newly created one called F first image. And just like that, we have a gallery version of our content map. In my case, the images are identical, which is boring, but you get the idea. By the way, you do not need to memorize these formulas. I keep them documented and updated in my wiki, which is linked in the description. Keep in mind that we can combine all these things. For example, we can build a tag-based content map across all our folders, as we just did, or again, limit the results to the current folder only, as we did in the previous chapter. Tags already free us from folder structures, but they still describe what something is, not how it behaves. The moment we want content maps based on status, progress, type, or workflow state, tags start to fall a bit short, and that is where property-driven content maps come in. Let me show you how that works. So far, we discovered content by location and by context. Now we move to another powerful model, content maps driven by front matter properties. We still use the same basis file that we created initially called dynamic MOC, and this is a key idea behind how I use bases. One base becomes the backbone, and then views are just different lenses, if you like, and visualizations. We duplicate the view, all folders tags, and rename it to all folders status. As you can see, our demo nodes all have the property status. Then we change the filter for the current view to return only nodes where the property status includes the value in progress. Now, this could be a list of ongoing activities for various projects, for example. In other words, this is a live, work-in-progress dashboard that we can update and not just a static overview. In our table, we see all the results across the vault and their properties. We can now sort them by progress by clicking on the column header. What makes this powerful is that we can now combine properties and context. For example, status grouped by tags. This can help us identify activities per project or topic, whatever it is. And this works with any property: status, priority, area, client, date, or workflow states. Completely up to us. And if you want to know how to visualize a progress number inside a basis view, I cover visualizations like progress bars and ratings in detail in a dedicated basis tutorial, the link to which is in the description, and I will also show you at the end of the video. So now that we have seen folder-based, tag-based, and fully property-driven content maps, the real question is, are bases really better than dataview or waypoint? As mentioned earlier, there are three common ways to build content maps. We can use bases, dataview queries, or the waypoint plugin. Each of them comes with different trade-offs. I look at three things. Ease of use. This includes something like quick start. How easy is it to get going? It also includes reusability. So once created, can I use a content map in other contexts? And last not least, also in this category, maintainability. If I need to do changes to my content map, can I do them in a single place, or do we have to touch multiple different items? The second one is flexibility, where I check things like customization. So how flexible is the result that I get when it comes to adding information? And second part of this, scalability. This is about how well each solution performs when my vault grows. And lastly, I try to assess its longevity. With that I mean how likely it is that each of these solutions will be around in the future. When comparing several options across multiple criteria, I like to use a so-called multi-criteria decision matrix. Sounds complicated, but it's really rather simple. I just add my criteria, prioritize them with a percentage weight, and rate each of them from 1 to 10. Okay, maybe it's not super simple, but it's really useful for decisions like this. Of course, all of these ratings reflect my own judgment. If you want to try it for yourself or ever find yourself in similar situations, you can download this template for free via the link in the description. For my priorities, Basis scores highest across ease of use, flexibility, and longevity. This results in a chart like that one, where the differences become very obvious. As long as our vault is small and its structure is stable, any of these approaches will work just fine. But as it grows and changes, the trade-offs in performance and flexibility start to be painful. Personally, I prefer a solution that reduces my work over time instead of increasing it. At the end of the day, it's about which approach keeps friction low and performance high. But all this is just me saying things. Let me show you a live comparison. In this next segment, I did not accelerate or slow down the screen recording at all. So everything is happening in real time. I opened 3 tabs, all showing the same image. Keep an eye on how fast they load when I switch to the various content map types. In the first tab, I switched to a node with our Basis content map embedded, listing the contents of folder A. Remember, there are approximately 10 files in here, so it's very small. The second one shows a node with a dataview query returning the same result. And the third one shows the same, but using the waypoint plugin. I think we can agree all 3 of them were reasonably fast and we did not really notice a big difference. Now let's do the same with folder C. Here we have about 1,000 nodes. Again, I open the Basis content map in the first tab. Still pretty fast. Now the one with the dataview query in the second tab. And we can see a noticeable delay already. And in the third tab, we have the waypoint version, which also performs very well. But of course, we have only the file names and no other properties, which highlights the trade-off between performance and flexibility. This real-time comparison shows that differences between these approaches become obvious already at around 1,000 nodes. In my own vault, which currently has roughly 4,000 nodes, using Basis noticeably reduces both waiting time and maintenance effort. For me, that translates directly into less friction and more consistency. I use Basis in dashboards, in the side panel, for habit tracking, and across my daily, weekly, and monthly notes. The key advantage is that the same base adapts to different contexts without duplication, simply by using different views. If you want to see more practical examples, take a look at this next video. It walks through real use cases from simple gallery and map views to more advanced patterns like progress bars and rating visualizations. All snippets and formulas used there are available on my website, linked in the description. And if you found this useful, consider subscribing and sharing with others whom it might help. More Obsidian videos like this are coming.